Hello everyone. For this tutorial, I'd like to discuss probability of independent events as well as compound events. An independent event is named so because its results or outcomes do not depend on previous outcomes, so the probability each time starts fresh. For example, a coin toss is an independent event because no matter what specific side you start at, the coin will always flip randomly back and forth between the two sides. If we have multiple independent events in a row, we can get the overall probability simply by multiplying the individual probabilities. Again, using a coin as an example, the probability of landing on one side is 1/2 normally, but if you flip it twice, then the probability of it landing on one side is 1/4. And if you flip it 3 times, the probability of it landing on one side is 1/8. Which should make sense. When you flip it twice, there are 4 possible options, and when you flip it 3 times, there are 8 possible options. Using formal notation, provided the two events are independent, the probability of A and B occurring at the same time is the probability of A times the probability of B. If we have two separate independent events that are for totally different scenarios, the total probability is still the multiplication of the individual probabilities, as this example demonstrates. If you are aiming to get a big prize, but you have to get randomly selected for winner circle first, and then get randomly selected from the winner circle before actually getting the prize, then the probability of getting to the winner circle from the diagram is 1/5. And once you are in the winner circle, the probability is 1/2. So this means in total, 1/5 times 1/2 is 1/10. So you have a 1/10 chance overall of winning the big prize, starting where you are at. I would also like to mention compound events, which is a formal way of saying events that are events of events. A compound probability is a probability of more than one event happening at the same time. For example, if we want to know the probability of rolling an even number on a die and then getting heads on a coin toss, we would see the probability of an even number is 3/6 because there are 3 even numbers and 3 odd numbers on a die, and the probability of a head in a coin toss is 1/2. 3/6 times 1/2 gives us 3/12, which can be simplified to 1/4. So the formula for compound probability is the same exact thing as the formula for independent events, which should hopefully make sense. If you looked at a diagram of the situation, or noticed intuitively that the probability of 2 independent events occurring at the same time is less than the probability of the events individually because of how there are more possible options overall. Now that we've explained how multiplication works in its most basic form for probabilities, we can discuss dependent probability next. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.